Hello everyone, my name is Siddharth Trivedi and today I will be teaching you about the stack data structure, and we'll also talk about some basic operations we can perform on the stack towards the end of our lecture. So to understand the stack data structure, let's take a very simple and perfect example of a stack, which is a can of Pringles chips. So let's assume this is a can and I'll fill it with some chips. Let's assume 6 chips. And I'll name them as 1, 2, 3, 4, 5 and 6 for the sake of simplicity. So here is a can of Pringles, and as you can see, the chip number 6 is at the top of the can, and it is also on top of chip 5, where chip 5 is on top of chip 4, or chip 3 and so on. As we can see that the chips in the can are arranged in a linear manner in a vertical column, and where each chip is either above a chip, another chip, or on the bottom of another chip, or both. One important thing to note is that here, as the chips are contained in a can, they can be accessed only from one direction, which is the top of the can, and we cannot access the chip from the bottom or anywhere else in the middle directly. We need to access them only from the top, and this is one of the most important property of a stack. Another thing is that the chips in a can follow a LIFO order. Now what is LIFO? LIFO means last in, first out. Suppose we were to remove a chip from the can, then we would remove it from the top. So like the first element to be entered into the can, which is element number 1, would be the last one which you would remove. So the last element which entered the can, which is the chip number 6, last in, would be the first to be removed out, then the second last, then the third last. This is what LIFO order actually means. So similarly, the stack data structure is a linear data structure where elements can be accessed, removed or added only from the top, and they follow a LIFO order. Now let's talk about some basic operations we can perform on a stack. Now every stack has a variable called a stop. Now this stop variable points to the topmost element of a stack, which here is the element number 6. Using this variable, we will be talking about two main operations that we can perform. The first operation is the push operation. Now let us name this stack as stack S. What push operation it does is, it takes an element and pushes it on top of the stack. So suppose if you were to do an operation called as push S, 10, where 10 is the value we need to add on top of the stack, then what this function would do is, it would add a new element here, and it will edit the top, update the top variable to now point at the new topmost element, which is 10. Another important function for a stack is called pop. As we have already established that the elements of a stack can be accessed only from the top, it is obvious that the pop will remove the element on top of the stack. So if you were to call the function s, and store it in a variable x, then the pop would remove the topmost element here, which is 10, and return it to the x variable. Now x is storing the value 10, and it will lastly update the top variable again to now point at the new topmost element, which is now again element number 6. Some other secondary functions for stack are top is empty, is full, and size. Now what these functions do is, the top function simply just returns the value stored currently by the top variable, that is the topmost element of the stack, and it returns it to the user. It does not remove the topmost element, it just looks for it and returns its value. The isEmpty function checks the stack and returns true if the stack is empty, and returns false if there is even one or more element contained in the stack at that moment. Similarly, isFull function checks whether the stack is full, and it returns true if the stack is at its maximum capacity, and it returns false if one or more element can still be added to it. The size function returns the number of elements that are currently stored in the stack. Now to talk about the complexity of these operations, all the operations, whether it be push, pop, top is empty, is full, side, all of these operations for a stack are computed in a complexity of big O of 1, which is really good complexity. So now we'll conclude this lecture, and I hope that you all have understand how the stack data structure looks like and how the operations are performed on it. Thank you.